Welcome back. This segment is about selection, or selectively executing lines of code in a C program. We start off by introducing the 6 relational operators in the C language, and then we go to if statements with or without an else clause. So we say if something is true, then do this, and we selectively execute some lines of code. There's one other construct in the C language that allows us to selectively execute code, and that's called the switch statement. And we'll look at the switch statement in this segment as well. I think that the easiest way of having you understand what these are used for and how to use them is to just solve some simple problems using them, and we'll go directly to the Visual Studio development environment and solve some problems as soon as we look at the operators and the constructs themselves. So let's start. Let's start off by talking about the relational operators that are available to us in C. Up until now, our programs have executed every line of code in order of sequence. So starting at the top and going to the bottom, and this is considered to be one of the control structures in C, sequence, which isn't much of a control structure at all. It means you start at the top and work towards the bottom. But the more interesting control structures are selection and repetition. So in this segment, we're going to look at selection, or selectively executing some lines of code in our programs. We need a way of making a decision about which lines of code to execute. So we're going to introduce here the relational operators in C that would allow you to write a relational expression. So there are 6 relational operators in C: greater than, less than, greater than or equal to, less than or equal to, and not equal to. You should notice that the equal to operator is 2 equal signs, which is not the same as gets, which is the assignment operator, or 1 equal sign, and the not equal to operator uses the exclamation point equal sign. So now you can write relational expressions that will evaluate to true or false. So 10 is greater than 5, that's obviously true, and you can use variables, comparing the value in variables. A is less than or equal to B, and that might be true or false, we don't know, because we don't know what's in A and B at the time. So these relational expressions evaluate to true or false. So we're going to write an if statement now to selectively execute code, and here's the general form. If, and in parentheses, a relational expression, if it evaluates to true, then we will execute the following line of code. Sometimes we would want to control the execution of more than one line of code, and we can do this with braces. So what's inside of braces is called a compound statement. The rule is an if statement controls one statement or one compound statement. So here's a little snippet of C code down at the bottom. If A is greater than B, then in braces, C gets 27 times B, and an output statement that indicates that A is greater than B. So the braces are not necessary if you have only one line of code here, but they don't hurt anything either. So sometimes people will say you should use the braces all the time, even if you have only one line of code. Some people do this and some don't. So you have to be ready to understand what's going on. If the programmer who has written the code that you're looking at uses the braces all the time, or if they rely on the rule that the if statement controls one statement or one compound statement. An if statement may or may not have an else clause associated with it. So in this case we have if milk is greater than 0, then do some lines of code, and then an else statement, do some other lines of code. So the else part is the false part. So if this is true, do this, else do that. An else clause never has a condition associated with it. It's assumed that the condition in the if has evaluated to false, and then we'll go and execute the lines of code in the else clause. And the else clause works the same way with the braces, the one statement or one compound statement. So it's easier to just look at the rules for how the if-else works in the development environment. So let's look at a problem that we would solve using if statements. So here's the problem. We're going to write a program that will meet this specification. We will ask the user how old they are. If they are 21 or older, then output a message that they can buy some beer. And if they're not old enough, then output a message telling them that they have to be 21 to buy some beer. So I'm going to take this small program specification into the development environment and we'll solve that problem. Okay, so I've taken the spec from the slide and I've added it here as a comment. So a block comment in C starts with a / asterisk and ends with */ and it's advised that you put your spec or some description of what you're working on in here so that you can remember what you were doing as you go along and also when you revisit this. So we're going to ask the user how old they are. If they're 21 or older, we're going to print a message that they can buy some beer, and if they're not old enough, then we're going to print a message to the contrary. So let's start out by declaring a variable that will hold the age, and then we will prompt the user to enter their age, and let's leave the cursor right there, no \n, and then when we do a scanf, we're going to put the format specifier for an int, and remember the ampersand on the variable name, and then let's echo back the age just to make sure that we got it right. You entered %i \n age, and I hope that you have paused and are typing along with this because it just makes it a lot easier if you do, as opposed to just watching passively where you don't learn as much. So let's make sure that this works. Enter your age. Suppose that the age is 55. You entered 55, so we know that we have the value getting into that variable correctly. So now we're going to write our if statement that meets the spec, and we're going to say if, and what do we want to compare? So we need to express something relational here. We're going to say age is something to do with comparing age and the number 21. So if age is greater than or equal to 21, then we'll output a message that they can go and buy some beer. Okay, and \n would be useful. And what's the rest of the spec? If they're not old enough, well, we could make another if statement here and say if the age is less than 21, but we could also more easily use an else clause. So we can say else printf, you must be 21 or older to buy beer. And I'll put a \n to go to the next line. And let's see if we have that working now. So if I enter my age and I'm 50 years old, then it echoes back, you entered 50, you can go buy some beer. So that seems to work. Let's run it again and put in a smaller number. If 18, it outputs the message, you must be 21 or older to buy beer. So it seems to be working, but what I would like to do is to just make sure that these lines of code are executing, and I'm going to do that in the debugger. So if we click out here, we get a big red dot that represents a breakpoint, and when we run in the debugger, you notice that it says Start Debugging. That's the button that we've been using to run our C programs. It will run the program and then it will stop right there at the breakpoint, and we can look at what's going on. So let's do that. Enter your age. I'm going to put 18 again, and now notice that the program has stopped running, and we have a yellow arrow here pointing at the statement that has not yet executed. So I'm going to make this a little bit bigger, and now click on locals down here. So here's what's going on. The program is running. We have down here under the locals tab, we have the current value in our variables. So we can see that we have a variable called age, its type is int, and it has in it right now the value of 18. We can also hover above the variable when we're in the debugger, and it will show us the current value in the variable. So 18 is greater than or equal to 21. Is that true or false? That's false, so we wouldn't expect this line of code to execute. We would expect it to go to the else clause and execute the else part because the condition has evaluated to false. So we have some new buttons up here when we're in the debugger. One of them is step over. That doesn't mean skip the statement. It means execute the statement that's being pointed at by the yellow arrow. So if we execute that one if statement, we see that the next statement to be executed is in the else clause, so it did evaluate this to false. This is very powerful. We can watch our code execute line by line and try to find any logic errors that are incorrect in our code. So we're now going to execute this statement, and you can go out to your program that's running and see what it's doing. So it's like running your program in very slow motion, and you can watch what happens on each line of code. If you get tired of doing that, stepping through each line of code, then you can just hit the green button again, the green arrow, and it will continue executing. So unless it hits another breakpoint, it will just continue running to the end. Okay, let's revisit our if statements. We didn't use any braces here, and we notice that each one line of code is controlled by the if, and one line of code is controlled by the else. I could have used braces. Let's put an open brace there and a closed brace there. And we didn't change anything in this case because we have only one statement being controlled by the if. And I could put an open brace there and similarly a closed brace there. And now some people find this a little more clear, even though there's only one statement in the if and one statement in the else. But these braces functionally don't do anything. If we had more than one statement, another printf here, so more than one statement to be executed in the if part, now the braces are necessary. So the if statement now controls two lines of code and the else statement controls one line of code. These braces are still not necessary because the else is independent from the if in some respects. It's controlling only one line of code or only one statement. The other thing that we might notice now is the indentation. So inside of the if we have two lines of code and they're indented, and inside the else we have one line of code and it's indented. This is necessary. The compiler doesn't see those indentations, but the human reader does. And it's expected that you will clean up your code, making the indentation correct so the lines of code that are controlled by the if are indented correctly. If your code gets messy like this, and your indentation is all messed up, you can ask the Visual Studio to correct the indentation for you, and you can do that by selecting all the code. Control A will select all the code, and then look under Edit, Advanced, Format Selection, and it will fix up the indentation for you. So there's no excuse anymore to have improperly indented code. You don't have to go through every line and fix it yourself. You just have to remember how to ask the Visual Studio to fix it for you. So inside of the main starts and ends with an open and closed brace. We have one layer of indentation, and then inside the if statement, which is inside the main, we have two layers of indentation, and as we nest these things together, the indentation will get deeper and deeper. So it's very important that your indentation be correct, because as you get good at this, you will look at the indentation to be able to read the code and find out what lines of code are controlled by what. Let's go back to the slides now and look at another spec. Let's look at the next spec now that requires selection statements for the solution. In this case, we're going to ask the user how much money they made last year, and we're going to calculate their income tax. If they earned less than $15,000, the tax is 0. If they earned $15,000 $25,000 or more, but less than $25,000, their tax rate will be 15%, and if they earned $25,000 or more, their tax rate will be 20%. And we're asked then to output the amount of tax that they will have to pay and their net income. So this problem starts to become a little more complicated, and it's a good idea, I think, for us to use some intermediate step that show that we understand exactly what this problem is asking. So here's a very common way of doing that. We make something called an IPO, or an input process output diagram, and this is a way for us to write down kind of an understanding of the problem that's being posed. So under the input column, we're going to write what the input values are in this spec. So you can read the spec, and it says, ask the user how much money they made last year. So we're going to write a variable name of income under the input column. As far as I can tell from this, there's only one input required in this specification. And then let's look at the output column next. We're going to output the amount of tax that they will have to pay and their net income. So there are only two things being output from this program, the calculated values of income tax and net income. And then under process, we can write little notes to ourselves of how we're going to solve the problem of going from the input value to the output values. So in this case, I've written that we're going to ask the user for their income, and then if their income is less than $15,000, calculate the tax. Else, if their income is $25,000 or more, which is the upper bound, then we'll calculate the tax, and else we'll calculate the tax for the middle range. And then when we're done that, we can calculate the net income by subtracting the income tax from the income and output the results. To make sure that we really understand exactly what this program is supposed to do, we can then make something called a test case, or several test cases. So for example, if the user enters 12,000, then our program should be calculating that the income tax is 0 and the net income is 12,000, or 12,000 minus 0 is the same as 12,000. So that's a test case. We can make the test case before we write the code to make sure that we understand exactly what the code should be doing. Here's another test case. If the income is 25,000, then we're in the mid-range, and we can calculate that the tax would be $5,000 and the net income would be $20,000. And in case 3, if they earn 25,000 or more, well, case 2 is also 25,000 or more. So is 5,000 20% of 25,000? Good. Good. It's very useful to make your test cases fall on the boundaries to make sure that you understand that the program needs to work on the boundaries, and it helps you get your less than equal to conditions exactly correct. And if you can't make a test case and show what the program is expected to produce, the exact values for different cases that the program is expected to produce, then it's impossible to write the code that actually does that. So let's go and write the code for this one, and I will take the spec with me, and we'll see if we can make our program meet the specification, and we'll test it using these test cases and see if we get the right answer. So we're in the development environment, and I took that spec with us about the income tax, and I've made a new project called income tax, and I've added a C program in there called incometax.c and made the main method. So we have an input process output diagram, and we have a set of test cases that we're aiming at. And we're going to try and write the code so that we could solve the solution using those tools that we created. So first what I'm going to do is I'm going to declare the variables for, let's use long int. It's what we really should be doing, except in the Microsoft compiler, int and long int are the same thing. You'll recall that. And let's declare the variables that we need for this. So we have income, net income, and income tax. Income is an input variable, and net income and income tax are calculated values that will then output to the screen. So let's ask the user to enter their income. Now we'll scan it in using %i for a long int, and don't forget the ampersand. And now we will start to test the value that was entered to see if, first of all, if income is less than 15,000, you can't use any commas there. If income is less than 15,000, I try to convince people to put their open and close braces at the same time and then type in between them. We calculate the income tax as being the income. If it's less than 15,000, the income tax is 0. So now let's put an else clause. Else, if the income is greater than or equal to 25,000, we will calculate the income tax as income multiplied by 0.2, which is 20%. And now the next else clause, which would mean that income is not less than 15,000 and it's not greater than or equal to 25,000, that puts it in the middle range. We would calculate the income tax as the income times 0.15, and all of these braces aren't really necessary, although I'm adding them in there to make it a little bit more clear. So we're missing one more brace. You can see them get bold, the matching ones, if you put the cursor. When you type the closed brace, it will show the open brace that's matching it. And remember, you can use Edit Advanced Format Selection to clean up your indentation. So for all three cases, we have the income tax calculated. Now let's calculate the net income, which is equal to the income minus the income tax. And then we can output the results. So the outputs in our IPO include the income tax and the net income. So let's compile this and see if I've made any typing errors. It says build succeeded. If it didn't, I would go and look for my syntax errors. It isn't expected that you would be typing code without syntax errors. Let's put a breakpoint there and then go and look at our test cases. So our test cases, what we expect this program to do, if we enter 12,000, the expected results are a 0 income tax and net income of 12,000. And let's run these test cases and just confirm that our logic is doing what we expect it to. So I'm going to run in the debugger. It says enter the income 12,000 with no commas. Now we've stopped at this breakpoint. 12,000 is less than 15,000. That's true. So if we execute that if statement, we see that the income tax is being assigned to 0. The else clause is not going to get executed because the condition was true. And we jump down to the bottom. Let me give you a little bit better view of that code. This statement, 12,000 is less than 15,000, was true. So we don't do the else clause. We jump down here to calculate the... Oh, well, there's a bug. I have an assignment operator there instead of a minus. I almost found it in the correct way. When you're in the debugger, net income is 0. Well, we should immediately recognize that something is wrong there. This is what the debugger is for, so I'm very glad that I made that mistake here. When you're looking at the code that you just typed, you see what you want to see. You will see something that isn't even there. But when you ask the machine to show you the execution of what you just typed, then you will see the mistakes. Everyone makes these mistakes, not just me. You'll also make these mistakes. And now we get to go in and correct the bug. Income minus income tax is the net income. So let's run it again. And we're going to put 12,000. 12,000 is less than 15,000. That's true, so the income tax is 0. The else, we skip that part. And now income 12,000 minus 0. The net income should be 12,000. And it is. And now here's the output. Income tax of 0, net income of 12,000, which was our expected result. Let's run it again with our other test cases. 25,000 was expected to be in the 20% tax bracket. So let's see if this if statement, well, what just happened? 25,000 is less than 15,000. That was false. So we jump to the else part. We're going to execute the else block. The first thing in the else block is if 25,000 is greater than or equal to 25,000, and it is because they're equal, so when we execute that if statement we should go in, and we did, you can tell by the yellow arrow. And now we'll calculate the income tax, and it turns out to be 5,000, which was our expected result. And we had one more test case. 30,000 should generate an income tax of 6,000. Let's try that one. And it's working. 30,000 is going to generate income tax of 6,000. And you know what's wrong with my test cases? I tested this line of code with 2 different test cases, but I didn't test this line of code at all. So what value of income should I have used to test that line of code? Something that's not less than 15,000 and not greater than 25,000. So some mid-range income amount like 20,000 would have tested that, and that's really should have been a test case to test each of the lines of code. So there's the third test case giving the expected results. So I made 2 mistakes in here. I made a syntax error when I put an assignment instead of a subtraction, and I also have a set of test cases that really isn't complete. So I hope that you learn from my mistakes as well as the things that I do right. And programmers will always be making mistakes no matter what. The objective is to get better, not be perfect. Let's go back to the slides now. Okay, we're going to look at the switch statement now. This is the only other selection construct in C besides the if or if-else construct. The switch statement is very specific. It allows you to take one of several paths in the flow of control. So in the general form, the switch statement looks like this. The keyword is switch, and then we evaluate some expression that evaluates to an integer value. It might just be an int variable, but whatever that evaluates to, we're going to then look at all of the case statements and jump to one of those case statements. So think of this as like a railroad switch. You have the train coming and you've got lots of different tracks that you could switch the train onto, and it can only go onto one. So those constants in the case statements must be unique. We can't jump to 2 different places, and they must also be constants. So the compiler needs to know that each of those cases is different. There is another keyword in here called break. If you execute the break statement, that means that we jump to the bottom. The execution of the switch statement is over, and a break statement is expected to be in each case. There's possible exceptions to that, but if you forget the break statement, then the execution will continue into the next case, which probably isn't what you want. There are some circumstances where it might be what you want, but it probably isn't. One more keyword in here is default. This is the default case. So if the expression doesn't evaluate to any of the others, any of the case labels, then we will jump to the default label and start executing lines of code there. So here's an actual piece of code that you might use a switch statement based on what the user enters. So in this example, you ask the user to enter a choice, and choice is an int variable. So we read this as switch on choice, and we have two cases, 0 or 1. If choice evaluates to 0, then we will jump to case 0 and start executing lines of code there. And if choice evaluates to 1, we will jump to that case and start executing lines of code there. And if it didn't evaluate to either of those cases, then we'll jump to the default case and start executing lines of code there. You probably wouldn't have used a switch statement if there were only two cases. Maybe some if statements would have been cleaner. A switch statement is often used when you have several options and the if-else statements just start to get too messy. Then a switch might be a viable option. Let's take this piece of code into the development environment and play a little bit with the switch so that we'll get comfortable with how it works. So we're in the development environment, and I copied that code off of the slide so that we could watch this switch statement execute. I put a breakpoint there. So all we do is ask the user for an int value, and then we switch on that value. So let's run to that, and let's say that the user enters 1. We're in the debugger, and we have choice as the value 1 in it. And when I go to the next line, what should happen is we should jump to the case 1, the one that matches the value that was evaluated here. So this might be a variable, or it might be an expression that evaluates to an int that would match the cases. In this situation, we have a very simple one. We jump to case 1 and we start executing, and then when we execute the break statement, the switch is over. We immediately fall out of the break statement. Okay, this time I'm going to take out that break statement. I'll comment it out, and this is a very common bug. That's why I'm demonstrating this. So we'll use the same value. The user enters 1. We switch on 1 and jump to the case 1 and start executing lines of code. But look what happened this time. Because there was no break statement, we bleed into the next case and start executing lines of code there. So in the output we have you entered 1, you did not enter 0 or 1, which both of those can't be true. So that's a problem with the switch. It's a common bug. Let's put that break statement back in. The default case is used when none of the other cases match. So if we enter a 6, choice has 6 in it, and we jump to the default case. The default case is very often used as an error case. You expect the switch to evaluate to one of the cases that you have, and if it doesn't, then it will jump to the default case, which very often will be used to spit out an error message of some kind. The order of these cases is not important, including the default case. It looks like we are evaluating the cases from top to bottom and then choosing the default case. It doesn't really happen that way. We look at all of them at the same time. Think of it that way. We look at all of the cases at the same time and jump to the appropriate place. So if the default case were at the top, it wouldn't have made any difference, although it would look a little bit strange because we expect the default case to be at the bottom, more of a convention than anything else. So we're switching on 6, and it will jump to the default case, which is at the top instead of at the bottom. So that might help you to avoid a bug at some point. Okay, the switch statement is a selection statement, not repetition, so we never see a loop going on here. We only see selectively executing some code. So we jump to a case label, and we execute code from there until we come to a break statement. Just a little summary of what we've done in this segment. We introduced the 6 relational operators, which should be familiar to you Perhaps the only tricky one is the not equal to operator because it uses the exclamation point equal sign. I'll say just a few more times, don't confuse the assignment operator with the relational operator equals. The assignment operator uses one equal sign, and we're going to pronounce that as gets. And the equal to operator uses two equal signs. All C programmers get these confused from time to time, and it's fairly difficult. So that's one of the places that you will trip. We also looked at the switch statement in the C language. This is another selection construct. When you switch on an expression and then you match the resultant value to the cases in the switch statement, the value of the case statements must be integers, they must be unique, and they must be constants in order for it to compile. And the switch may or may not have a default case, which would cause the program to jump to the default case if it doesn't match any of the others. The switch statement in C has a very limited capability. You can't use it to express ranges of values, or you can't use it to switch on double values or floating point values of any kind. But it is very useful in very specific circumstances when you have one of several branches that you want to take in the execution of your program. Well, I hope you've enjoyed the segment on selection, and it's starting to get a little more interesting. You'll be able to write some programs that have a little more meat in them. I'll see you next time.